but you delivered the first box, the first chips, to Elon Musk, who was one of the founders of OpenAI, only a couple of years ago. What happened?
Well, I delivered to him the first AI supercomputer the world ever made. It took us 5 years to make it. It's called a DGX. It's everywhere in the world today. People think that we build GPUs, but this GPU is 70 pounds, 35,000 parts. Out of the 35,000, 8 of those chips come from TSMC. It is so heavy you need robots to build it. It's like an electric car. It consumes 10,000 amps. We sell it for $250,000. It's a supercomputer, so it takes another supercomputer to test it. This is a computer first of its kind. And we started working on it in 2012. It took me 5 years to build it. At first, I built it for our own engineers. And I spoke about it at one of our conferences, and Elon saw it. He goes, I want one of those. And he said, he told me about OpenAI. I also knew Peter Beal, who was a Berkeley professor. He was one of the early people at OpenAI. And Ilya Sutskever, I met him during the AlexNet days 5 years earlier.
He's involved in all the drama that we've been reading about.
And so anyways, I delivered the world's first AI supercomputer to OpenAI on that day. And people took pictures of it, and it's on the internet somewhere. Yeah.
When you did that, and you said you didn't do it originally for him, what was it, though, that you saw at that point, 5 years before you even delivered it?
In 2012, when this all first happened, AlexNet did something remarkable. Here's a neural network. It's a software program where the way you programmed it was to show it the results that you wanted, which is the backwards of most programs up to then. You know, programs up to then were engineers would sit down and you would write software, and then you would test it to see if it produced the outputs you wanted. But here, you showed it examples, and you taught it what outputs you wanted, what outputs to expect. And so when we first saw the results of it, AlexNet, the results were so spectacular that Alex Krizhevsky and Ilya Sutskever and, of course, Geoffrey Hinton, they achieved results of computer vision recognition that no computer vision expert was able to achieve before that. And so the first observation is how remarkable it was. But then we were fortunate enough to have taken a step back and asked ourselves, what is the implication of this to the future of computers? And we drew the right conclusions that this was going to change the way computing was going to be done. This was going to change the way software was going to be written, and this was going to change the type of applications we could write.
Was there any part of you that was scared when all of this happened? You just mentioned 2 names, George Hinton as well. You also mentioned Ilya, and those are names, by the way, if you've been following what's happening. They have been very outspoken about the dangers of AI. Very well, I want to get into actually what you think happened at OpenAI in the past couple of weeks. But it may very well be that there may have been a new step change in terms of what this technology was. But was there ever part of you, when you're seeing this all happen, say, oh my goodness, not only we're on the cusp of a revolution in a great way, but that this is dangerous?
Well, no, I would say 12 years ago, nobody expected the results we would get. And I think anybody who would have said so back then would have over-exaggerated, our understanding of the rate of progress. There's no question that the rate of progress is high, and what we realize today is that of course what we can do today with these models and intelligence are related but not the same. We're very good at perception today, and we're very good at those one-shot knee-jerk reaction. I recognize that that's a dog. I can finish that sentence. But there's a whole bunch of things that we can't do yet. We can't reason yet. This multi-step reasoning that humans are very good at. AI can't do that.
And how far away do you think we are from that?
Well, we'll see. We'll see. I think that just about everybody's working on it. And all the researchers are working on it. Everybody's working on it. We're trying to figure out, how do you take a goal, break it down into a whole bunch of steps, and create a decision tree, and then walk down the decision tree to figure out, which one of the paths leads to the most optimal answer. This is how we reason through things, how we iterate through a problem. Today, as you know.
But you're making bets now in terms of technology that you have to build and investments you have to make.
Yeah.
On where we're going to be 5 years from now.
10 years from now.
10 years from now.
Yeah, right.
So, people talk about AGI.
Yeah.
Right? Artificial general intelligence.
Yeah.
Do you think in 10 years from now we are there?
Depending on how you define it, I think the answer is yes. And so the question is, what is AGI? If we define AGI as a piece of software, a computer that can take a whole bunch of tests, and these tests reflect basic intelligence, and by completing those tests, deliver results that are fairly competitive to a normal human. I would say that within the next 5 years, you're going to see obviously AIs that can achieve those tests.
And
now,
design the chips that you're making right now?
Yeah.
Will you need to have the same staff that designs them?
In fact, none of our chips are possible today without AI. Literally, the H100s we're shipping today was designed with the assistance of a whole lot of AIs. Otherwise, we wouldn't be able to cram so many transistors on a chip or optimize the algorithms to the level that we have. And, software can't be written without AI. Chips can't be designed without AI. Nothing's possible.
We started by talking about OpenAI, and everybody's focused on that. What did you make of what happened? The ousting of Sam Altman, the return of Sam Altman, all of it.
Yeah, well, first of all, I'm happy that they're settled, and I hope they're settled. It's a really great team, and they're doing important work, and they've achieved great results, and I'm just really happy that they're settled. It also brings to mind the importance of corporate governance. I mean, NVIDIA is here 30 years after our founding. We've gone through a lot of adversity. If we didn't set up our company properly, who knows what would have done. And so I think when you're architecting an industry, you want to apply some of that wisdom to architecting a company. And so I'm really proud of NVIDIA's corporate governance, by the way. And if not for the architecture that we established when I was 29 years old, it'd be kind of hard.
You're a for-profit company, though. What's so interesting, I think, about this sort of dynamic is that is a firm that is effectively operated from a governance perspective as a not-for-profit. And one of the reasons that they set it up that way was because they did think it was dangerous. Elon Musk said it was dangerous at the beginning. Ilya said it was dangerous. And so the question is, in the sort of multitude of these different businesses that are in AI, do you think you do need these not-for-profits? Do you think that the incentive system is just fundamentally off and should be a for-profit? I mean, a lot of people now think the capitalists have taken over.
Well, regulators are not-for-profit, and we should regulate these. First of all, just take a step back and think about what AI is. AI is an autonomous system. It's an autonomous system that's it's an autonomous information system. We have a lot of autonomous systems today. Self-driving cars in factories, within factories already exist. Robots are autonomous. Planes are autonomous. Autopilot, self-landing. All of those capabilities exist. We ought to make sure that we apply the first principles of autonomous systems in the same way. We have to design it properly, test it properly, stress test it properly, monitor it. There's inside-out safety. There's outside-in safety. The FAA, flight air traffic control, redundancy, diversity. There's a whole bunch of different systems that we have to put in place for autonomous systems. There's a lot of industries to learn from.
At the beginning of this, I mentioned there's sort of a frenemy situation going on with a lot of companies that use your chips. They're desperate for your chips. They want your GPUs, and at the same time, they're also trying to build their own, frankly. I'm curious, since you've seen it all, how you would stack rank the success of the various companies that are in this AI space. We have somebody from Google DeepMinds here today, their COO. I'm curious where you think OpenAI ranks in that. There's inflection. Amazon is trying to play in
I'm not going to rank my friends.
No, but you have a sense of, and I part of the question
I'll
is...
admit it, I want to, but I'm not going to do it. No, I'm just kidding.
But there is a question about actually whether all of these things converge. Meaning that they all, that does this all become some kind of commoditized business?
No, I don't think so. I think what's going to happen is we're going to have off-the-shelf AIs, and these off-the-shelf AIs are going to be really, really good at solving a lot of problems. But you're going to have companies in healthcare are going to have supervised, super tuned AIs that take these off-the-shelf AIs and make them super good at drug discovery or super good at chip design. Let me just use our company for example. The vast majority of our company's value is in the data and the intelligence and the know-how, the craft that's inside our company. And none of that data is out on the internet. You can't get an AI to go learn it. And so I've got to take a really smart AI, which is what we do. We build a smart AI, and then we teach it how to design chips. We teach it how to write software. You teach it how to do drug discovery. You'll teach it how to do radiology.